Okay, so we're sort of getting towards graphing sine, cosine, and tangent functions are basically trig functions. And the things that we're interested in are the following. We're interested in the amplitude, the period, and the phase shift. These are going to be three important terms that we're going to be looking at when we graph trigonometric functions. Okay, so what is an amplitude? So let f be a function. Okay, now, and that's also obviously it has to be a periodic function. Okay, then let capital M be the maximum value of f and small m be the minimum value. Okay, then the amplitude is defined by amplitude is 1/2 of absolute value of capital M minus m. Okay, and that's going to be my amplitude. So what does that mean in a function? So let's think about our sine function. Okay, so my sine function goes something like that. It's a periodic function, so it repeats. So I'm just going to draw one cycle. We know that this is our maximum value, that is 1. Okay, and here we know this is minimum value, which is -1. So this here will be my capital M, and this here will be little m. Okay, so in this case, what is the amplitude of my sine function? Well, my amplitude is going to be, let's call that a for now, and my amplitude a is going to be 1/2 of 1 minus -1, which is 1/2 of 2, and that is going to give me 1. So the amplitude for the sine function is just going to be 1 here. Okay, and that's basically this height. It's half the height of my function. Think about it as half the height of your function. What's the height? The total height of my function is this. Half it, and that's going to give me my amplitude. Okay, now obviously things will change if I multiply the sine function by something, right? So in a sense, if I had y equals sine x, we know that my amplitude is going to be 1. Okay, well, what if y equals, say, 5 sine x? So let's think back now to our transformations, right? What does that 5 do? If you remember, if gx equals a times fx, well, that is a vertical stretch or vertical compression, right? Now, since a, which for us is 5, since that is greater than 1, this is going to stretch the function in a vertical direction. That's going to make it taller, right? And so my function, instead of my original sine function, say, which was 1 about here, right, now gets taller. So it's going to go to like 5 and -5. So the width will remain the same, but now my function becomes really tall, right? That's my new sine function. And so my amplitude now is going to be 5, right? Because the distance, this is 5, this is 5. And so the distance between the min and the max is going to be 10. And so half of that distance is 5. So my amplitude for this function, right, for this function, my amplitude is going to be 5. Okay, so make a small note here that for the function, or rather for the functions, a sine x or a cosine x, the amplitude is given by absolute value of a. Okay, we just want to remember amplitude is always positive, and so we're going to denote it by absolute value just so that if I do get a to be a negative number, right? For example, if there's -3 sine x, the amplitude still would be 3 because that would be the stretch, okay? And what happens in this case, right? The range of my sine function was -1 to 1. Well, now it got stretched from -5 to 5, and the range is going to be negative absolute value of a to absolute value of a. So for this function, my range, right, my range for this function is going to be -5 to 5. So let's briefly talk about period. We've already seen this term before, right? So what is a period of function? That's when the function repeats, right? So basically, let's say this is my function, right? And let's just take a sine function here. We know that this is 2 pi. We know this is 0, right? So this is basically the shape of my sine function. And then if I go ahead from 2 pi to 4 pi, which is the same length, my function is going to go back this way, right? And it's going to keep repeating. Here, from 0 to -2 pi, my function is going to repeat again, right? So basically, the shape from 0 to 2 pi is repeating, and that is what is the period of a function. So basically, you can think about when the values of my function start repeating, right? So this length on your x-axis, this range, right, where I get all the different values of my function, that is my period, okay? And then once I have the period of the function, all I have to do is basically cut, paste, and copy this shape all over, okay? So that's the period of my function. And the third thing we know here is the term phase shift. Now, you all know what phase shift is. You just know it by a different name. And for us, what phase shift really is it is our horizontal, right? It's the horizontal translation or shift. So that's a horizontal. If you remember your section on function transformations, right? We looked at amplitude and we looked at that was nothing but the amount of stretch that is in the function, the vertical stretch. This is going to be a horizontal shift. That is my function moving to the right or is my function moving to the left? That is what your phase shift is. How much is it moving to the right? How much is it moving to the left?